A new wave power generator. Objective: obtaining energy from relatively small lake waves. Found a way that worked. And worked surprisingly well. See how in this video. Obviously, there are numerous ways to obtain energy from ocean waves, some functional, others not so much. The thought here was that if we could build a simple system to obtain enough energy from 3 to 4 inches of lake waves, it should be simple to scale the system for larger waters. So here are our findings. First, the float. In order to get a vertical motion from a float that matches the altitude difference of the waves, the float has to be just a float, ideally containing no more mass than absolutely necessary. If we look at the following curves, we understand why. Sample 1. Here, using a float that contains very little mass, like a balloon. The red curvature depicts the actual wave and the green depicts the curvature of the float. Here we can see that the float just about follows the curvature of the wave. Sample 2. Here we use a heavier float with more mass. Again, the red curvature depicts the actual wave, and the green curvature depicts the curvature of the float. Two things happened. The amplitude or the vertical motion of the float decreases, and we will have a lateral phase shift to the right. We have a similar situation on the receiving end, especially if we would transform this oscillation into rotation, and obviously that is not the only way to generate energy. Consequently, in that case we need to accelerate as little mass as possible. Also, trying to directly accelerate a large diameter router, like in a generator, would be much harder than rotating a 1-inch axle even if they held the same mass. To transfer the lifting force from the float, I used a stainless steel cable from the anchor, passing through the float and then via a Bowden cable housing, similar to the brake cable on a bicycle, to the power unit. That way I do not add any weight to the float and the power unit can be freestanding as there are no forces pushing or pulling on the unit. In addition, the system is self-adjusting for different lake levels, like tide, and can support numerous floats. The float used in this sample was a 19 by 19 inches by 4 inch thick styrofoam float with a volume of about 23 liter or a lift/pull capacity of about 50 pounds. This is a picture of the prototype power unit, where the cable from the float operates on a pulley, actuating the drive shaft via a one-way bearing. There is also a one-way bearing in the bearing block for the shaft. Unit in operation. That was just the prototype, to see if the theory worked. I know the generator would be limited in its output due to the low RPM, and I am modeling a gearbox to boost the RPM. However, I'm not convinced that a direct drive is the way to go, as the key to make this work is not having any mass for the wave to accelerate. To go around that, I am looking at winding a quill-type spring that, when fully wound, will release its energy driving the generator. That way we have almost no mass to accelerate while we have plenty of force from the float to wind the spring. Granted, we do not have an even flow of electricity, but for charging a battery that is not needed. So here is my next generation power unit. Slightly larger to be able to deal with a stronger spring, but same principle. Operating of a kneeboard for a float might not be ideal, but it proved the point. With the use of this larger float, and bigger diameter pulley, the force of rotation on the axle becomes dangerously strong. Well, that's it for now. Looking for a stronger quill spring but have not found one yet. So stay tuned.